Hi everyone, Clev here. Today we're going to start Chapter 1, and 1.1 is identifying points, lines, and planes. Undefined terms. Words that do not have a formal definition, but there's an agreement about what the words mean. So in geometry, the undefined terms are point, line, and plane. A point. A point has no dimension, and it's represented by a dot. So if I look at my picture here, I see a dot and a capital A right next to it. That A is going to be the name of the point. So I'm going to call this point A. A line. A line has one dimension. It's represented by a line with two arrowheads and extends without end. Arrowheads mean that the line goes on forever and ever. It will never stop. If I look at my diagram here, I see that there are different ways to name this line. The first way is I see this lowercase l, or a cursive L. If I see a cursive or lowercase l, or any type of letter kind of floating above the line, I know then that that can be a name for the line. Also, we can name lines by using 2 points that are on the line. And if you look, we see point A and B are located on the line. So I can call this line AB or line BA. It does not matter the order of the letters as long as you use 2. Plane. A plane has 2 dimensions. Through any 3 points not on the same line, there is exactly 1 plane. Here's our diagram once again. The 3 points I see are points A, B, and C, so I can name this plane ABC. Also notice that all 3 of those points are not on the same line. You cannot connect them and create a line, so those are the points that I can use. Finally, I see this uppercase M. There's no dot by it, so that is telling me the name of that plane, plane M. Collinear points. If I look at that word collinear, I see the word line. So collinear points are points on the same line. Coplanar points, I see the word plane. So coplanar points are points on the same plane. Here's our first example. For part A, give 2 other names for line PQ and for plane R. So I'm going to rewrite my answers here. All right, so if I look at line PQ, that's this line right here. Right away you might see this lowercase n. It's floating next to the line, which means I can name line PQ line N. Also remember, P and Q are points on the line. I can flip-flop those points around to name the line. So line Q, P. For the second part, give 2 other names for plane R. Okay, so I'm going to outline the plane R. To name this plane, I am going to use 3 points that are not on the same line. So plane, what 3 points do I see? I see a V, an S, and a T. Those 3 points are not on the same line, so that one works. And plane, what other letters could I use? How about P, T, V? All right, for part B, name 3 points that are collinear. What does collinear mean? It means that the points are on the same line. So I see that SPT, those are collinear. Name 4 points that are coplanar. Coplanar just means points on the same plane, but remember, they cannot all be on the same line. So I can actually use any points here except for point Q, because if you look at Q, it's floating above the plane. So I'm going to use B, S, P, and T. So those are coplanar. And even though S, P, and T, they are on the same line, since V is not on that line, then I'm good. So all these points are coplanar together. Next, define terms. Terms that can be described using known words such as line or point. A line segment. A line segment stops the line. So if you look at this green line segment, we don't see any arrowheads because it means that it's actually stopping. Endpoints are where the line stops. So as you can see with these arrows, these points here are the endpoints. It's what stops the line to create the line segment. Array. Array has one endpoint and one arrowhead. So it means that it's going to start at the arrowhead and then continue on forever. When you hear the word ray, sometimes people think of a sunshine or the sun. And so just think about the rays of the sun start at the sun and then go out. Opposite rays are rays that are opposite. So if I wanted to write 2 opposite rays here, I could write out this ray, which would be ray BA, or if I just write BA, I'm going to put a dot above the B because that's where the endpoint is, and then draw a arrowhead above VA. I also see that I have a ray here, so I can call that ray BC. When I write this out though, I want the endpoint to be above the B and the arrowhead above the C. This cannot be flip-flopped. If we switch that arrowhead around, we would be talking about a different ray. Example 2. Give another name for segment GH. So if I look at segment, and we're talking about the endpoints, what name could I give that? Well, I can just flip the points around, and this could be segment HG. For B, name all rays with endpoints J. Which of these rays are opposite? All right, so I see that J is here in the middle. So there's going to be 4 different rays that start with J. So the first one is going to be ray JH. What's the opposite ray of JH? It would be ray JG. So the endpoint is above J, the arrowhead is above G. What's another ray that we see? How about JE? Remember, the endpoint is above J, the arrowhead has to be above E. What's the opposite ray of JE? It would be JF. Intersections. 2 or more geometric figures intersect if they have 1 or more points in common. The intersection of the figures is the set of points the figures have in common. Some examples of intersection are shown below. So two lines that intersect, their intersection is going to be a point. So point A is the intersection of line M and line M. The intersection of two different planes is going to be a line. So we see the blue plane and the red plane. The intersection there is going to be that line P, or I'm sorry, line Q. Example 3, sketch intersections of lines and planes. So for part A, sketch a plane and a line that is in the same plane. I'll give you a second, see if you can sketch this out. All right. Hopefully your sketch looks something like this. So I have plane A, and I have a line here. So this line is inside plane A. B, sketch a plane and a line that does not intersect the plane. So here's my plane, and here is my line. I see that this line does not intersect my plane, and I'm done. And finally, sketch a plane and a line that intersects the plane at a point. So here's plane A, my line that goes through the plane, and the intersection, I just put a B. Use the diagram at the right. For number 5, it asks, name the intersection of line PQ and line K. All right, so let's look at our diagram. I see PQ is here, line K is here. If we remember a couple slides back, it said the intersection of two lines is a point, and that point is point M. So point, I'm just going to put PT for point M. 6, name the intersection of plane A and plane B. I'm actually going to erase what I did before. So let's outline plane A. So plane A is here. Plane B is here. So what is the intersection? It's kind of hard to see, but we do have a line here. Remember from a couple slides back, the intersection of two planes is a line. So we see that lowercase k, so we know it's line K. I'm going to erase that again. Number 7, name the intersection of line K and plane A. So line K is here. Plane A is here. And this is a trick question because we have a plane and the line is on the plane. So it would just be line K. Next, we're going to go back to algebra. So using algebra, determine if the point is on the line, yes or no. Well, how can I determine if the point is on the line? I have a point here, here's my x value, and here's my y value. So all I have to do is plug in the x and y into my equation and see if I get a true solution. So y is 20, 6, x is 2, plus 8. So 20 is equal to 6 times 2 is 12, plus 8. I end up getting 20 is equal to 20. So is that point on the line? Yes, it is. So let's try A similar problem, determine if the point is on the line, yes or no. Y is equal to 2x plus 3. So 1 here is my x. 6 is my y. I'm just going to plug it into my equation. So 6 is equal to 2 times 1 plus 3. So 6 is equal to 2 times 1 is 2 plus 3. So 6 is equal to 5. Is this point on the line? The answer is no, because we know 6 is not equal to 5. It's not a true solution, so this point is not on the line. Graph the inequality on the number line. Tell whether it's a segment, a ray, point, or a line. So x is greater than or equal to 3. The first thing I need to look at is this symbol, greater than and equal to. That means I'm going to have a closed dot. So I want to go to number 3 on my number line, and I'm going to do a closed dot because it does include 3. X is greater than, so where am I going to shade? To the left or to the right of 3? I'm going to shade to the right. So all the numbers to the right of 3 are greater than 3. So is this a segment, ray, point, or line? It's a ray. I have an endpoint and an arrowhead. Graph the inequality on a number line and tell whether it's a segment, ray, point, or line. So I look at my inequality sign, less than or equal to. Once again, that's going to be a closed dot. My number here is -2, so a closed dot at number -2. X is less than -2, so what numbers are less than? Where am I going to shade? To the left of -2 or to the right of -2? I'm going to shade to the left of -2. So is this a segment, ray, point, or line? It's a ray.